So here we've got, it's uncharged, this capacitor, and we've got a switch here. So I need to do this. That's the switch. And so first thing is draw the circuit, calculate the time constant. Right, the time constant, tau equals RC, so that's just 3 times 10 to the 6th, 3 mega ohms, times 0.1 times 10 to the negative 6. And so this gives me 0.3 seconds. Okay, so that's the time constant. Now I want to know the charge on the capacitor and the current through the resistor at these various times. The first one is after one time constant. So 1 is actually really easy. The charge on the capacitor, Q, so let's write it this way. Q at 3.3 seconds, that's after one time constant, is going to be 0.67 times the maximum charge that can be on here, given by the EMF times this, right? So it's 45 volts times 0.1 microfarads. And I think the answer turns out to be 284 microcoulombs. The charge after one time constant will be, this will be 63%. Sorry about that. And this will be 0.37. And the current, the maximum current is going to be given by V over R. Right, so 45 volts over 3 times 10 to the 6th ohms. I think that should come out to about 5.52 microamps. Right, so that's 1. For 2, now this is after 2 time constants, and we don't have a special percentage that we can just remember for that. So let me put these over here. 2. Charge as a function of time is given by, and charge is increasing, right? So this is going to be the EMF times the capacitance. So let me just write that. That's the maximum charge rate, Q equals CV. And since it's approaching an asymptote, it takes this form. 1 minus e to the negative t over tau. And so for this, all we're doing is we're plugging in 45 volts. This is 1 microfarad. This is the 0.3. And honestly, I don't have the number written down, but as long as you plug the numbers in the right way, the form of the equation is the important thing. And then the current as a function of time will be given by the EMF over the resistor. And since this is decreasing, that takes the form e to the negative t over tau. Okay, and then 3, all you're doing is plugging in into here 1.5, right? And for number 2, you're putting in 0.6 as time.